The second part of Trivia Game version 2 presents a challenge for your understanding of numerical instructions. Let's take a look at it. So at this part, I ask you to remove the start pilot light from the judge, and also the player's fall light and yell light should be gone. Instead, we combine all these into a double integer indicator called status. So with this, it has four different values. 0 represents reset. If the value is 1, represent the player got a fault. And if the value is 2, represent the game is at the start phase. And if any of the player one's status get the value of 3, that represent the yellow light state. All right. So on the interface, you can see one of the status. Right. There are 3 status for each player. Right. They all have 4 possibility values and 4 possibility status on the HMI. All right. So in your logic, for the rest of your logic, all the start PL, fall light, or yellow light should be gone. They should be all replaced by this status integer. Right. Let me clear out. Then we can do a demo on the final result. All right. So over here, I can have here. All right. So let's get like right now. You can see the. Let me move up a little bit. All right. So right now, underneath the status, you can see all the 3 players. They are reset at the reset state. Haven't started yet. So judge press the start, and you can see all the 3 status be changed to start, equivalent to the start PL. It just distributed into 3 players. Right. So if player 3 press the button, it got yellow light, right, and also correct. Can add a 10 point, wrong can add minus 10 point, right? You got the same as the part 1, right? In the same time, player 2, player 1 cannot get yellow light turn on, right? So this is the one scenario. So if judge haven't pressed the start button yet, you can see all the indicator has the reset, right? So if player 1 press button, got a fault. Right. Same thing for the other 2 player. Right. So in the same time, you do the score minus 5 point thing. Right. So that's what you're supposed to do with the logic. Right. So this is the final result. Let's talk about how do we design that. So before we move on to the design of the this trivia game, let me do a brief review on the previous lab. When we learned the integers, right? The second last part, you can see the comparison, right? So let me bring up the here the integer lab. All right. So this is the logic associated with this part. Alright, so you can see right now the input value is 0 compared with 100. It shows length. Right, on the PLC programming design, we have 3 separate indicators, 1, 2, 3. Right, and right now length is energized, which is the indicator 2, because this length instruction become true. Right. On the different design, in parallel with that, we use a double integer compare indicator. You can see here, all the 3 rounds use the same double integer, but different value. Right. Value 0, value 1, value 2, because we have 3 different scenarios, equal, length, or greater. Right. So with this, we can set up the HMI with that. Right. So you can see if you have a value greater than 100, you can see here the indicator 3 will turn on because this one is true, right? This one greater become true, and then the compare indicator change value 2 that corresponds on the HMI as a greater. Right. So by that time, I want you to realize the advantage over double integer, you can see here with 100 equal. Double integer has so many different values can be used to represent so many different states. In this case, only 3. In trivia game, we use 4. In compare with the Boolean tag, we have to create 3 separate tags, right? So if we have 10 different scenario, we have to create 10 different Boolean tags. But with double integer, we can only use 1 tag with 10 different values to represent the status. On HMI also has an advantage, right? With different Boolean tag, you have to create different objects, like a 10, right? If you have a 10 scenario, you have to have 10 different objects on HMI. But with double integer, you can use one multi-state indicator with different values, with 10, 100, doesn't matter how many states you have, right? So that's what we learned on the integer lab, right? So I just want you use the same logic, so you can design in the trivia game, right? Like I said, it's quite of a change, quite of a transition from the Boolean logic into double integer thinking, right? But we can practice, improve on that, right? So let's do it together. So there are a few things we can do with that over here. I'm gonna just use this sandbox to start to convert the Boolean logic into double integer, right? So before we do that, I have to do some changes, right, in order to be able to run this sandbox. You don't need to worry about that. I just need to make this sandbox JSR running, all right? So I have my sandbox here. So before we start, all right, if we go back to the lecture, right, remember what I just demonstrate on the integer lab, right? Let's read this part again. You can see here, compare instruction are equivalent to Booleans exam on, exam off, because they all return to either logic true or logic false, can be used as the base input instruction to energize output. You need to think in this way now, right? So the compare instruction will be just greater than equal for those kind of instructions. All right. So let's look at the lab we have in the version 2. So in that lab, I gave you some help with the transition, right? The convert, right? So let me get this on here. So for example, in the logic, if you want in the Boolean logic, you energize star PL, right? So based on the value we have 0, 1, 2, 3, right? So 0 reset, 1 jump start fault. Number 2 is the game start. Number 3 yellow light, right? So that's why we move value 2 to player 1's status. I just use player 1 as an example, right? Of course, player 2, player 3, same, because they all have the same status, right? So that's why you use the source as the immediate value of 2 down there. And then in the same time, in your old logic, Boolean logic, if you unlatch the pilot light, right? So we need to change this instruction into either clear or move. I just use move to be consistent, right? Same thing, move 0 as a source to the status, right? Status that represents 3 different players, because the value 0 represent the reset at the beginning. All right. So once you understand this, you understand, okay, so if you want to indicate player 1 has a fault, right? Before, that's a Boolean tag, use large, but now you need to move that, transition that into the numerical instruction. Actually, you want to move indicate fault. Fault jump start is value 1, so that's why source need to be 1, and then same thing, status. So that's very easy for you to understand that you can make the transition, right? So that's not very difficult, right? Then over here, let's look at the instead of large unlarge, now in the logic we have the exam on, exam off. That has some thinking we have to do. So for example, if we want to check if the game start or not, right? We can just use exam on start pilot light, right? For that we have to think about how can we get the true and false in the double integer, right? So we use equal, right? With this the game start, you can see again 4 different value: reset, jump start, start, and yet. So that's why we check the player 1 status equals to 2. So if that is true, so that means game already start, right? Same thing for the other 2 players, right? So now you can see we convert from the exam on into double integer into numerical instruction equal, right? Because they have the same function, right? They return either true or false, right? You can use which you can base on to make the decision. All right. So the other thing is that sometimes we also need to check. For example, if we want a setup if there's a fault, right? We also need to check the game haven't started, or if the any player got a yellow or not, right? So for that you have to think about it, right? So because we use the exam off for both condition, right? The second one is relatively easy. So you can see here if we want to check if player 1 yellow haven't turned on yet, right? So we can use NEQ. And the player 1 status, well, I just use ST, not equal to yellow. Yellow is 3, right? So not equals to 3. We should be okay with this, right? In the moment you will see that we will demo, right? The other way is that I want to show you there are different ways to have the same result, right? So you just need to practice your thinking. The most challenging part is that with the game haven't started yet, right? So mostly probably the first thinking will use non-EQ here. With the same thing, we'll just use player 1 as an example. Player 1 status not equal to haven't started, right? So that means not equals to 2, right? So this could be a problem, right? So if we think in this way, by the first instinct thinking, we will see that there's some problem, right? I hope I can use the emulator to demonstrate that what's going on, so then you can have a better understanding. All right, so let's go back to the design. All right, so we can start to design this on the trivia game version 2. All right, so okay, so you can see here, right, the first 2 rounds, that's the version 1 star PL judge, right? Then that's player 1's fall, player 1's yellow, right? So if we can convert this, pretty much we can do the similar thing for the other 2 players, right? So let's look at here. The star PL, like we said, all right? So before we launch star PL, right now we don't have a star PL, right? On the HMI, there's no star PL anymore. And then we have to change that into double integer, right? So this we have to use move. We move the game already start, right? Game start is 2. We move 2 as a source to player 1 P1 underscore I think it's called status. I already created that. Yeah. Alright, so we can convert that into this, right? So of course you also need to let me do this one. Okay. Control C, Control V, Control V. Alright, so this one we can just change to player 2. You have to create those tags already. I already have those tags created already. Alright, so that's the first round. If I finish on there, right? So then you can see over here we convert that into the double integer, right? So now right now, if I press the start, you can see they all change to start, right? And then when I press reset, based on this logic, right? When I press the reset button, this one gonna be true. It's still using the old logic. It doesn't work, right? It cannot clear it, right? So we have to do something out here. So we can do this. I'll do the copy paste, Control C, select all three, and then online edit on this, delete on this, and then we can Control V. So then this time we can use clear, right? Or over here I just use move 0 to the destination, right? So in this way we can make a consistent on the move instruction. So now let me try if I can clear that. Right now all the status are start, right? So if I press reset, then I'll go back to reset, right? So again, start, all start, reset, right? So we convert that into the double integer instruction. So alright, so let me do this yearlight first. Right, so let me do this yearlight first. You'll see why I do the yearlight first. Alright, so the you can see here P1 yearlight, right? So the game must already started, right? So with that we don't have the start PL anymore, right? So in order to check game start, we can only check the status. So with this we can only have the equal, right? So remember how do we check the game start, right? So player 1, right? Actually it doesn't matter. I'll just use the other way, right? So value 2 represents the game start, right? So value 2 has to be equal to player 1 underscore status. So that'll be the condition equivalent to a game start. And player 1 press button, that's still boolean, so keep that. And then we have to check the other two players haven't got the yearlight turn on yet. Remember we use the non-EQ, right? So I'll just use the NEQ to represent that. Alright, so for this we'll use the not player 1's yet, it's player 1's status, right? So status not equals to yet is the value of 3, right? So that'll be on that. So that's we will use this to replace this. So it's gone. And then with player 3, if you understand, we can just copy and paste. Control. Oh no, I have to undo it. Right. So you can see it's very similar to the Word. Right. So Control C first, then Control V, and then we can use the player 3 status to do that. And not done yet, right? So in this last one, we large the player 1's yearlight. So we don't have yearlight anymore, right? So then we have to use different way, right? So we have to move, right? So we can use player 1's status, Control C and Control V, right? So then we can delete that. So in this way, we can move 3 into the destination. So player 1 got a yearlight. Alright, so let me finalize. If we can try if we can get that one. Alright, and let's try it. game start, right? Game start, and player 1 press the button, yellow light turn on, right? Because value 3 move to there. Then you can reset, go back to the initial state, right? And player 1, this one, yeah, this one we don't need it anymore, right? You can see here, right? So we already did that reset, move to the 0 into status, right? We already tested it. So this one is gone. This whole run is gone. We can finalize, we can do the same thing on there, right? So let's try again. All right, let's try the game start. All right, and player 1 press button and press reset to clear it, right? So we have that, right? So now we need to do the fault, right? So like this, when player press button, right now nothing happened, right? Because we still have the old logic. We only latch the fault light, which doesn't exist anymore, right? In the logic, we can think in this way, right? So obviously, with this one, if you want to set up the fault, right? It's supposed to be move to jump start is value 1, right? So value 1, change to value 1 on here. Then we can delete this Boolean logic anymore. We can put do that, and we don't need that anymore. And then same thing for the this run. Let's look at run number 4. We use reset to clear the fault, right? We don't need that anymore. Same as the yellow light, right? We already have this move 0 in there, so we can delete, then finalize. Once we finalize, let's look at here. No, not yet. So that's the key on here. So we still rely on this start PL on here, right? Which doesn't exist in this part anymore, right? So we have to use the Boolean, we have to use double integer status. So with the start PL exam off, right? Remember on here we talk about this part, right? So we can have a different design, all right? So let's try this one first. If we have the non-equal, right? Not equal. So actually, that's not a very good way. We can do that. We can use the here Control C. I want to show you a different way. All right, player 1 press button before the game start. Right. So Control V. So we have here. We can double click MOV. Right. And then no NEQ. Right. So you can, if you for this way, you can do this way. Status non-EQ to start is 2, right? So we change that value to 2. So we think this will work, right? Because game start represented by value 2. So if not equals to 2, that means game haven't started yet, right? So let's try it out. So if that game start, then fall light, that's right, that's correct. But the problem is, once the game start, we had this before, right? Game already start, player 1 press the button, but the instead of the yellow light come on, we had before, but the fall light come on, right? What exactly is going on, right? So let me see if I can show you by the help with the emulator, right? Remember, I demonstrated this before. With the emulator, we can have a very useful function called the single scan. All right, so that's very useful. Okay, so right now it's continuous, right? So game start, right? Says that's game start, right? So now I need to run the single scan. So run continuously. No. So now I need player 1, toggle player 1's button. So right now the PLC operation is suspended by this, right? So if I toggle it to simulate the button being pressed, right? You can see the button being pressed, all right? So we will run one scan. We will run one scan, see what happened, right? Let's just simulate that. So if I press no, all right, see what happened, right? So we have the emulator on, right? So that's which is right? You can see here, because we move 3 into that, right? Into the status, right? So that's according to run number 3. That's right? So, but if I run again, if you look at that, if you look at this instruction right now, run number 2, because you can see here we already have status equals to 3, right? And the non-EQ will become true, right? 3 not equals to 2, and then you will move 1 into status, right? So if I click no again, you will see the 1 move into there. One status into value into 1, this EQU will become false, and then you will not get opportunity to move 3 to the status again, right? Right now you can see value is 3. Everything is good. We got a yellow. That's correct, right? The next, once I click this, the next scan, right? So because the value 3, this non-EQ will become true, right? Button is still pressed, right? And then you will have a value. Right now the blue arrow shows number 3. You will see value 1 in here, right? So this is what happened on run number 2, right? With run, then PLC will start to scan run number 3. When PLC scan run number 3, the status, you will see the blue arrow, you will see value 1, right? Because you already assigned move 1 into that, and that because the EQU instruction will result as a logic false, right? Even though the button is still pressed, and no matter what's the result after that, because you have a logic false, those following instruction will not be executed. So you will never get a chance to run 3 into the status. That's what happened. So even though with the single scan you have the chance for yellow, but we didn't see it because PLC run very fast, right? So now I'm going to click no. You will see that, right? You will see the yellow change to fault, which is wrong, right? You can see here, fault. And also you can see the value change to 1. Alright, so the problem with this is that we understand that, right? So this is just a not very good conversion, because non-EQ to 2 is too wide result. Alright, so you have to think about this. So what we are trying to do this right now, we are trying to indicate player 1 got a fault if player 1 press button before the game start. So this basically we want to describe game haven't start yet, not start yet, right? When game not start, how do we represent that? But we choose a very bad representation on that. We use non-EQ equals 2. So that's what I'm saying. It's not very accurate, right? So if we think about the value, right? We have the 0, 1, 2, 3, right? 0, 1 reset, 0 reset, 1 is the jump start fault, 2 start, 3 at yet, right? So why don't we just use value 0? Because value 0 represents the starting phase. So the better choice on here will be EQU 0 instead of non-EQ 2. So in this way, we can solve that problem, right? So that let me do that. Right? Let's do this, and then also we can get rid of the one scan thing. All right. So because I already show you on that, right? So let me just replace that reset. All right. Okay. So this is something we want to change, right? Non-EQ change it to EQU. EQU, and then the destination should be 0 here. All right. So with this, we finalize. All right. So you can see here with the we don't need an emulator once again anymore. All right. So let me see if we can move it this way. Okay. Yeah. So now let's try player 1, right? Before the game start, reset, right? Player 1 press button, got fault. That's right. He got a fault. All right. And game start, right? All start. Player 1 press button, yellow. Oh, we got it, right? So that's exactly what we want to do. All right. All right. So this is something. One thing. Common, very easily run into problem like this, right? Instead of the non-EQ, right? So, and I want to show you the other options over here. You can see here, over here, this non-EQ is safe because this is the part when the player 1 press button after game start, right? So, yeah, so it threw me off a little bit. So I think I'd better change back. All right. So normally this is not the way. It's legal, but not many people program in this way. All right. So start and 2, value 2 represent game already start. All right. So after game start, so you can see here after game start, right? After game start, player 1 press button, the other 2 player not equal to 3. That means they haven't got the yellow on yet, right? So the other option is that we could use, let me press reset first. If you're doing, you want to try a different way, non-EQ, if you don't like it, you could use EQU. This is player 2, right? If player 2 status not 3, right? So but over here we can use value 2. So that means player 2 status still at the start, right? That's equivalent to the not equals to 3. So you can see I haven't changed for player 3 yet, right? So that's before, right? So now if I just leave it in this way, I want you to see the same result you can get, right? So that's what I mean. Different design, you can get different same result, right? So you can see here. Let's try game start and player 1. If we got the yellow, yes, that's right, because they are the same thing, right? So that's safe either way. So it's not like all the non-EQ is wrong, it's not good. Then you can see that, right? That's a different way. Again, I just want you to understand with double integer, it has different values, right? Different values has different meaning. So it's not like the Boolean only 0 or 1, true or false, yes or no, right? It's more complicated. So that's why you need to think about more, right? So over here, if you remember, if any player got a fault, you don't want the judge to start the game, right? So we haven't considered that yet, right? So if you want, you can do this way, non-EQ, right? So we can drag to here, NEQ, right? So if we just consider player 1, right? Player 1 and not fault, right? jump start is 1, right? So then we can do this, not equal to 1. So we consider that we add that into the logic, right? So reset, you can see if player 1 press button got a fault, and then judge cannot, you can see here, judge cannot start a game, right? So that's non-EQ 1 because right now it got a fault, right? So the other way, right? So I just want to show you on here, judge press the reset. I only do that the player 1. You remember, you also need to do the other 2 players, right? So the other way is that you can use EQU, right? So 0, that means reset. That means better do this way. I have everything in here. Ctrl+C, Ctrl+V, Ctrl+V, right? So we can do this way, and then player 2 status, player 3 status. Make sure all the 3 players, they have the status equals to 0. Then we can move 2 into the let me try this way. If it's too long, you can also do the parallel, right? It really depends, all right? So if you want or not. So let me just, so okay, so let me just drag this in here, and also add level. Then we can drag this player 3 into here. So in this way, I can have a nice layout. You can see the final design, right? Of course, there's only player 1 in there. You need to add the other 2 players, right? So just start a game, need to make sure those 3 players, they all got a status into 0. Then you move 2 to all of them, right? So reset and start. Yeah, we have everything, right? And then player 1 got a yellow light, reset, and player 1 jump start and cannot start the game and reset. All right.